Ladies and gentlemen, good evening. Tonight we're going to talk about Kubernetes, and I'm not going to show you anything technical tonight. I'm just going to talk about the terminology. So when I show you something maybe in another video, then you would know what we are talking about and what all of those fancy words are and what Kubernetes actually does. So if you don't know it, Kubernetes is a cool deployment and environment handling system that actually can scale up your Docker containers, and it can also scale them down again, of course, so it actually fits the need. Let's get right into it, because I've created this cool Archimate diagram right here. So it's actually, if you know Docker Swarm, then this will probably be quite easy for you to understand. Docker Swarm is also a system where you can actually deploy your application, and then it will actually scale up and down when it's needed. And it's kind of the same with Kubernetes, but it's very easy to use, and it's it is awesome. So it's also a little bit difficult to understand. So don't be sad if you don't understand it all at once. Sometimes Kubernetes has a short name called K8 instead, or else if you want to read more information, then you can go to kubernetes.io, and the documentation is awesome, but there's also a lot of it. And if you just want to get started, then I would recommend that you install Minikube on your own machine, and then you also install kubectl, the CLI tool for your computer, and then connect that to the Minikube. I'll show this in other videos. It's just if you want to fast forward and actually try it out for yourself, and then maybe spin up a Nginx Docker image, or spin up your own container based on your own image. Then you can just do that quite fast instead. But first of all, now I'm going to, if you're still there, then I will just explain to you what a Kubernetes cluster actually is, and the terminology, because sometimes the short name is K8 instead of the Kubernetes. So if you search for K8 on the internet and then on some problem, then it should be related to Kubernetes then. We have a cluster right here, and inside a cluster we can have something called a namespace. A namespace is quite smart, because then I can create a namespace named Mike, which means that I'm actually, it's a kind of a mini cluster inside the cluster that you create. That means that I will not bother my coworkers, and I will not bother production when I have this namespace inside the cluster. So namespaces are awesome, and it's very important that you use namespaces. You don't have to use namespaces if you don't want to. And to begin with, when you just spin up and run stuff on your own machine, maybe you will use the default namespace. But I would recommend that you actually think about namespaces, and yet you also set a namespace that is not the default namespace. It's also a way not to pollute the global cluster with configuration and with the pods in general. So now we have the next term we need to know about. That is a node. A node is where pods can run on, and a pod is something that can contain one or more Docker containers. Yes, you heard right. It can contain more than one Docker container. But it is actually, I would say, if you're in doubt, then don't only use one pod per container, because the problem by stuffing more Docker images and Docker containers into one pod is that you cannot scale them by themselves. Maybe you have a database. The database only needs to be in one instance, and then you have your application, like in this situation. You would actually like to scale your application into two instances, and you would like to do that split over two different nodes. So the node is actually where the Kubernetes program is actually running, and that is where it's actually placing your pods. So a node is like kind of like it could be a virtual machine where you have installed Kubernetes, the Kubernetes nodes program there. And if you ever need to upgrade your Kubernetes cluster, then you would do that by upgrading each of these nodes, because that is where they actually run. That is the server that runs the Kubernetes pods. And the pod, that is where your application actually runs. So that is the smallest unit, if you will, inside the Kubernetes cluster. And inside your pod, you can have one or more containers. In my situation right here, I only have one Docker image, one Docker container based on a Docker image that running in each pod. And I would definitely recommend you to use that setup. I would not recommend you to mock more to stuff more than one Docker container into one pod, because of the scaling. If you usually want to scale them separately, the database, for instance, and your application. Okay, so then now we have a node right here, and we have one instance of my application, and I have another node with another instance of my application. Then I have a Mongo database that my application is using, and that is only that only exists in one instance, in one pod instance. It only runs in one pod. And how can my app actually communicate to the MongoDB? It would not go directly to the pods. That would be a no-go. That would be it is probably possible, but it's not best practice. What you would do is you would go through a service. That means that you will create a MongoDB service, which we have right here, and that MongoDB service would then point to all of your MongoDB pods. So that means that if you had multiple MongoDB pods, then whenever my application communicates to the MongoDB server, then it would there's actually some logic behind it. So it would not choose it would try to use a MongoDB instance that is on the same node as the calling pod, as the calling application. So it'll actually try, if I'm on node 1, if my application is on node 1 and it wants to communicate to the MongoDB service and store some data, then it would actually use the MongoDB instance 1 because it is on the same node. If I had another MongoDB instance 2 on the node 2, then that would not be used unless, of course, node 1 is heavily used. Maybe the performance says that it should actually use the other one instead. There are some logic, so it's not just a random round robin communication that's going on when you connect to a service. And the same thing. Then we have. I also have my app as service right here. So that means that if I want to communicate to my application, then I will communicate to my app service, and that my app service would then have access to my two pods right here. So in this situation, it is a web application that I've created, and then I have something. Then we have something called config maps and secrets. Config maps and secrets, they live per namespace. That means that you cannot access configuration maps and secrets in other namespaces. You can actually access services from other namespaces, and that is very useful if you have a set of default services placed in one namespace, and you don't want to spin these default services up inside each namespace. Maybe it's because it's costly, and maybe because it's a bit complex to spin those up. Or maybe just because there's no reason to do it. So then you can actually go to and communicate to another namespace, and then communicate to a service inside our namespace. But you can never use the configuration maps and the secrets inside another namespace. And what are those config maps and secrets used for? Yes, they are actually used for. You can actually use them inside your scripts when you are inside your Kubernetes deployment scripts. Then you can set some configurations as environment variables. You can also set some secrets as environment variables. The difference between secrets and configuration maps are that the secrets can be a bit more secure. You can make them more secure. You can encrypt them and stuff like that. When it's secrets, when it's config maps, then it's just a key value map. And I've not mentioned HashiCorp Vault or Asia key store or anything like that, or any of the other key stores. Google, most clouds actually have a key store. There's a lot of products out there. I've not mentioned that in this drawing right here, but you should actually, I would say that you should actually not place your secrets directly inside your Kubernetes cluster, because if you give someone administrative access to your cluster, then he or she can actually go in and read these secrets right here. This should be placed in some kind of vault, also so you can circulate your secrets. But to begin with, when you start with your first application and with your start, then you can keep it inside the Kubernetes cluster, and they have done an effort to actually make it secure. Also by encrypting it, as I said. So then we have another thing, that is ingress. And we have one ingress controller for all namespaces, but we have ingress configuration per namespace. So that means that we have one controller, Ingress controller, that then picks up configuration from each Ingress, from each namespace, and then it will actually route. Maybe it could route all the traffic that goes to. Let's say that I have a domain named codeinvestigator.com. Then I can route all the mike.codeinvestigator.com traffic to the namespace named Mike and to the service named MyApp. Rules like that can easily be set up in Ingress, and there are different implementation of Ingress controller. The most common one is the Engin X one. There's the Engin X, or that's at least the one that I usually use when I set up my own stuff. Feel free, if you have other information than what I tell you right here, then feel free to leave me a comment. So that's actually it, Ingress controller, where we can route traffic in. So that means that when I start up a browser and I go to mike.codeinvestigator.com, then my service, then the traffic, the request will be routed to my service. My service will then go to maybe port 1 or port 2, and then maybe if I reach port 2, then port 2 will then communicate to the MongoDB service, which again will communicate to the MongoDB on instance 1, and then after it extracted some data from the database, then it could return that as a REST response, maybe, or maybe as an HTML response. That could also be nice, right? So that's actually how it works. This is Kubernetes cluster. I hope I explained to you, how it works in a nice way. And if you want to forward, and if you cannot wait for my other videos to be made, then you can then go look for Minikube and go look for kubectl. And if you want to be very cool, then you will not call it kubectl. You will not call it a kubectl. Then you will say kubectl every time you write kubectl. Then you will just say kubectl, and then you are one of the cool Kubernetes persons. Yeah. Is there anything else? I think I mentioned most things. We will come to the way you deploy stuff to the Kubernetes cluster is you can of course use the kubectl, the kubectl, but I would actually recommend you not to do that. I would recommend you to create YAML files, and that is also best practice, and that is the standard way. So you will create a YAML file where you will describe what kind of deployment you want and what kind of Ingress rules you want to set up. But I will show you all of this in another video. I want to thank you very much for watching this video here, and I hope to see you again soon. Have a great evening. Bye bye.